Okay, here comes another question from my cousin in Tennessee about factoring by substitution. And this is helpful sometimes, although the question that she gave me for an example is kind of silly to factor it this way. Well, I don't know, if you're not good at factoring, it might help. But we got x to the 6th minus 8x cubed plus 15. Now, if you're good at factoring, you can kind of antifoil this in your head and come up with the answer. But if you're not good at factoring, that's where substitution comes in. Make sure exponent numbers here, remember base and exponent. Make sure exponent numbers are a little easier to handle. So for substitution, what we're going to do is we're going to take our lowest common factor, what we normally pull out, which is our lowest power of x here. And we're going to put something smaller in there to take its place. And I'm randomly going to choose z as our substitute. You can choose pretty much any letter, but I is one of the big ones that actually already has a meaning. So we're going to choose z. And we're going to say that z equals x cubed. So we've set this to equal our lowest factor of x. So that means when we come down here and we rewrite our problem, everywhere that we see an x cubed, we're going to stick a z. So, and as far, okay, you're saying, okay, look, this is x to the 6th. That's not an x cubed. What do we do about that? Well, remember, because of the power rule of exponents, if we have x cubed and we square that, this is a power to a power, and that's just multiply them together. So x cubed squared is x to the 6th. So what we're going to do, since there is an x cubed in this, is we're going to put our z, and then we're going to give it an exponent to account like over here. So this is like taking the cubed and squaring it. So again, I'm going to say minus, then we have an 8. I'm just making this really colorful. Again, we have an x cubed, so we're going to throw a z in there because that's our substitute for x cubed. And plus 15. I'm just going to put constants in orange. Even though 8 is a coefficient and 15 isn't, they're both constants, that's why they're both in orange. Okay, so now we have something with some smaller numbers that we can anti-foil a little bit better. So we want to look at a couple things here. We want to look at z squared. We know that's going to just split the z and z when we make our little anti-foil down here and get our two factors. So we look at our two constants here, and we have negative 8 and positive 15. So this tells us a couple of things. It tells us that since these signs are opposing, both of these down here have to have a minus sign in them or a plus sign in them. But since we have a minus here, we know they both have to be a minus sign. So we know that. Okay, the next thing we want to look at is when we look at 15. What are our factors of 15? Which is what can we multiply together to make 15? So we got 1, 3, 5, and 15, because 1 times 15 is 15, and 3 times 5 is 15. Now we want to look at that and go, do any of these add up to 8? And we say, oh look, 3 and 5. They can make 8. So now we're going to go back to our problem here, and we say, okay, we know that z squared is just going to simply split into z and z. Because, you know, we just took, this means there are two of them, we just took one here and put one here. Again, we know these both have to be negative. And since these signs are the same, it doesn't really matter where we put our 3 and where we put our 5. If these signs were different, it does actually make a difference because you may be adding and subtracting to make a different number here. But since they're both negative, it doesn't make a difference. Now, to check this, now we've got a factor like this, we're going to FOIL it. Which just means we're going to multiply these two binomials, because they have two numbers, together and see what we get. Z times z is z squared, negative 3 times, z times negative 5, outside numbers, is negative 5z. Negative 3 times z is negative 3z. And negative 3 times negative 5 is positive 15. Now since this is a z and this is a z, we can take these two coefficients, which is the number in front of the z, and put them together because they're like terms. And negative 5 minus 3 is negative 8, so we get negative 8z plus 15. So we see this trinomial, which has three numbers that we've got here, matches this one up here. So we know we did our factoring right. But we have another step to do, because if you look up here in the question we're actually asked, there's no z. So we've got to get rid of that z and put it back the way it was. So we're just going to reverse the process. Now everywhere we see a z, we're going to put an x cubed. So we come down here, and set it up. And we know that our constants are going to be the same, our 3 and our 5. All we got to change is our z back to an x cubed. So this has got a z, that's an x cubed. We got a z, this has got an x cubed. Now, if you FOIL this out, you should get this number up here. I'm going to leave that for y'all to do. But I FOILed it out earlier. I promise it does come out with this number. If you have any questions, you can just put them in the comments. And thanks for watching.